Hello everyone, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session, we have completed the thermodynamics and KTG chapter, right? Chalo. So today we are going to deal with the new chapter, that is the simple harmonic motion. So here in the lecture number 1, we are going to deal with the basics of the simple harmonic motion. First, what is simple harmonic motion, what is periodic motion, what is oscillatory motion, what is harmonic motion. So all these things we are going to discuss in detail first. So then we'll go for the equation of S.H.M. So most of the students, they face difficulty in simple harmonic motion, that is oscillations or S.H.M chapter we call, right? So we are going to divide this lecture, total chapter, into 6 lectures. So and each topic I'll discuss in detail and I'll do n number of questions so that the concepts and the question solving skills you can improve, guys. Chalo. So without wasting much time, so let's get into the today's topics. So what are our today's targets? First we'll understand what is the periodic motion, then what is harmonic motion, and in the harmonic motion what is the simple harmonic motion. Then we'll go for the basic terms related to S.H.M, which is very important, and the questions related to it are very important. And then we'll go for the equation of S.H.M. Chalo. So these are our 3 main targets for today's session. So as usual, I just need your attention for the next 1 hour, guys. Just be with me, avoid all the disturbances around you for the next 1 hour. And at the end of the lecture, it's very important to prepare your own short notes. Chalo. So without wasting much time, so let's get into the today's topic. So what is periodic motion? So anything which repeats itself after regular interval of time, so is called the periodic motion. Okay. So in the uniform circular motion we have studied, right? So let's say if the body repeats itself after a particular interval of time. So consider, so the object has started here, so it's making the uniform circular motion. So it started from here and again coming back to the same place after certain interval of time. So again it started from here, again coming back to the same place after certain interval of time. So this is called the periodic motion. So which repeats itself after a regular interval of time. So in the NCERT, so you can see one line. So an insect climbing wall and falling down as shown. So as shown in the sense like, so it will climb and fall. So again it will climb and fall. So climb and fall. So which repeats itself after a regular interval of time. So this is also a periodic motion. Okay, so the simple definition is which repeats itself after regular interval of time is known as a periodic motion. That's it. So I'll give number of examples. See, so you can write the motion of a bouncing ball. If there is no energy, energy loss, if you throw a ball, then what happens? It bounces. Again there is no energy loss, again it bounces to the same height. Again there is no energy loss, again it bounces to the same height. Practically it's not possible because there will be some energy loss. So but if we consider ideal situation where there is no energy loss, so after certain interval of time the ball bounces back to the same place and again hits the ground, again bounces back, so it continues. So that's also a periodic motion. So and then the motion of planets around the sun, so in the gravitation we have discussed already, and the rotation of earth after certain interval of time again, so the earth rotates, so the rotation of the earth, and the motion of pendulum. So if you observe the simple pendulum, so what it does, so it moves from mean position, this is called the mean position, and it goes to the extreme position, this is called the extreme position, and again it comes to the mean position, and again it goes to the extreme position this side. So these basic terms you already know. I'll focus more on the questions here. Direct definition based questions or example based questions can be picked. Okay, so periodic motion, only one definition which repeats itself after regular interval of time. That's it. Clear? Chalo. So the simple harmonic motion or the motion of a pendulum is an example for the periodic motion. Chalo. So let's see next one. So then what is oscillatory motion or the harmonic motion? So what is oscillatory or the harmonic motion? See here. So to and fro motion, the oscillatory motion and or the harmonic motion, it's a type of periodic motion. It's a first thing type of periodic motion. Remember this point. It's a type of periodic motion. Done. So in the periodic motions, the to and fro or back and forth motions are called the harmonic motions or oscillatory motions. That's it, the simple definition. So the periodic motions are the ones which repeats itself after regular interval of time. In the periodic motion, which makes a to and fro motion or back and forth motion, so are oscillatory motion or the harmonic motion. That's it. So the simple example I can give, so the motion of a pendulum. So if you consider the pendulum here, so what it does, so it makes the to and fro motion. So it moves to the extreme position, again it comes to the mean position, again it moves to the extreme position, again mean position, again extreme, mean, extreme, mean. So to and fro motion, right? This is called the simple harmonic motion. Understood? Chal. So and then not simple harmonic motion, harmonic motion or the oscillatory motion. What is simple harmonic? We'll discuss. So in the spring mass system, so let's say, so you have attached a block of mass m to the spring, a block of mass m to the spring. So now you released it from the rest. So what it does, so it oscillates back and forth. So the back and forth motion, back and forth or up and down motion about a fixed point. So this is a fixed point, about that point, so it oscillates up and down, up down, like that. So and here about the mean position, it oscillates. This position, the fixed point, so that fixed point is called the mean position, we call. This is a mean position. So here it repeats after it repeats itself after regular interval of time. But what kind of motion? Again, so to and fro or back and forth, like this. Okay, here we consider ideal situations where there is no energy loss. If there is energy loss, it will not oscillate for the n number of times. First it oscillates, it moves to the some extreme point, then so it will move less to the extreme point. Previously it reached, let's suppose here, so then later it will reach here, so then later it will reach here when there is an energy loss. But we consider so the ideal situations for the oscillatory motion. So the fixed point about which body oscillates is called the mean position or the equilibrium position. So we discussed, right, this position is called the mean position or the equilibrium position. So what are the examples of the oscillatory motion or the harmonic motion? Simple spring mass system and motion of a pendulum. Clear? Understood? So is oscillatory motion a different motion or the periodic motion? It's a part of periodic motion. In periodic motion, the to and fro and the back and forth motions are called the oscillatory or the harmonic motion. And now, so let me discuss. So all oscillatory motions are periodic. Yes or no? All the oscillatory motions are periodic, but all the periodic motions are not oscillatory. But so I wrote here, yeah. But all periodic motion are not oscillatory, but all oscillatory motion are periodic. So we consider there is no loss of energy. There is no loss of energy. Clear? Chal. So I gave the flow chart also, the oscillatory motion, harmonic motion versus simple harmonic motion. So the simple harmonic motion, first we will discuss the simple harmonic motion, then we'll go to the previous slide. See, so I gave, so which repeats after itself is a periodic motion, and in which, so the to and fro and back and forth motion is a oscillatory motion or harmonic motion. For any harmonic motion, you can give this equation. F is equals to minus k into x to the power n. This is the equation for any kind of harmonic motion. The general equation for the harmonic motion or the oscillatory motion. It's a general equation for harmonic motion or oscillatory motion. So now in this, so this k is called the restoring force. This k is called the restoring force. Now, so this n will take the values of odd numbers. So the n will be equals to 1, 3, 5, 7, so 9, so like that. It will take the any odd value. So now in this simple harmonic motion, in place of n, if you put 1, so that is called the simple harmonic motion. So this is any kind of harmonic motion. Okay. So now what is simple harmonic motion, sir? So if you place n is equals to 1 here, f is equals to, if you place n is equals to 1, so the equation will become f is equals to k minus kx to the power 1, not minus 1 here, it's printed wrong. So it's a 1, right? So the equation will become f is equals to minus kx. So this is a equation of force in the simple harmonic motion. Understood? This is the equation for S.H.M. S.H.M. Done. So this is for any harmonic motion. It's not the simple harmonic motion, it's any harmonic motion or oscillatory motion. So it can be complex, like here it can be, you can take 3, 5, 7, it will not take the even values. Done. Chal. So good. So this F is called, it's a restoring force. What does it mean by restoring force, sir? It always acts towards a mean position. So let me tell you. So here, let's suppose, so the body has started from mean position. So then F is equals to minus kx, right? So right side, the x is positive. If the particles are moving towards right, so then what the system will do? The restoring force will act to the left. Yes or no? If x is positive, so F is equals to minus kx. X is positive, right side, right? So then it will be minus, like that. And then F is equals, let's suppose if the particles are going this way, so then x is negative, so then the restoring force will act towards right. If x is this side, the x we take it as negative, towards the left. If x is negative, so already negative into negative, positive, F will become positive, which means it acts right. So if you observe, if the particles are moving towards the extreme, right extreme, so the restoring force is acting towards the mean. If the particles are moving towards the left extreme, so the restoring force is acting towards the mean. So the restoring force F is always towards the mean position. Important. The restoring force is always towards the mean position. Very, very important point. Done. Chal. So now, so let's see the, here we can write, yeah. So now you can see the periodic motion, so which repeats itself after regular interval of time. Under periodic motion we have oscillatory, harmonic or non-oscillatory. Okay, under oscillatory or harmonic motion, again the simple harmonic motion. So where the F is equals to minus kx. F is equals to minus kx. Done. Understood now? Chalo. So let's see further. So the condition for a S.H.M is the F is equals to minus kx. This is the condition for S.H.M. Okay. So now let me elaborate this case. So let's say this is a mean position. From mean position, so if the particle is moving right side, x is positive this side and this side, so we take x is negative. So then observe carefully. So the restoring force opposes the particle's motion. No, this statement is wrong. Restoring force will not, restoring force, understand this statement guys, restoring force opposes the particle's motion. No, so this statement is wrong. Why? See here, sir, particle is going this side, so here the restoring force act towards a mean, and the particle is going this side and the restoring force, so it's opposing the particle's motion, right? No, because let's suppose the particle is coming from here, the particle is coming from here, so then which side the restoring force will act? Restoring force is always towards a mean, it acts towards a mean. Here particle's motion from extreme to the mean this side, and restoring force is also this side. So the restoring force F, the only definition you can write, the restoring force F, it is always towards a mean. That's it. Don't say that it is opposite to the particle's motion. No, it supports a particle's motion also. Always towards mean. So most of the students think that, so the restoring force is the one which opposes the particle's motion. It supports also. See here, if the particle is coming from this right extreme to the mean, so the restoring force is also right extreme to the mean. If the particle is coming from left extreme to the mean, so the restoring force is also left extreme to the mean. It supports as well. Understood? Clear everyone? Chalo. So this equation you have to remember, where K is the restoring force and X is the displacement from mean position. X is the displacement of particle from mean position. Done? Clear? Chalo guys, let's move further. So now I can write one more statement here. We can write where we can write. So I'll write here. So here, if greater is the displacement, then greater will be the restoring force. If greater is the restoring force, displacement, then greater will be the restoring force. So F is directly proportional to minus x. Yes or no? F is directly proportional to minus x. So greater is the displacement, then greater will be the restoring force. Greater will be the restoring force. Clear? Understood everyone? Chala. So the simple question, so try this question on your own. Everyone, a particle is moving in a circle with uniform speed, So this is a circular motion. So the particle is moving with a uniform speed. So its motion is periodic and simple harmonic. The circular motion is not a periodic motion, it is, but simple harmonic no. So the harmonic motions are to and fro and back and forth motion, not the circular ones. It is periodic but not simple harmonic. So correct. So it is non-periodic. No, it is periodic. We have seen, right? So it is none of the above. No. So it's option 2 is the correct answer. Done. Yes, simple question. So here a particle moving along the x-axis executes simple harmonic motion, then the force acting on it is given by, if it is making the simple harmonic motion, the force acts on the particle will be the restoring force. So what is that restoring force formula? F is equals to minus kx, that's it. So F is equals to minus kx. So see for the option. Here some constant added, so no problem. So you can just take the minus a into kx, where a is some constant. Done, because there is no direct kx. So it is along with some constant a. You can take. Chalo. So this is important. So based on this we have to solve n number of questions. Understand this carefully. So understanding S.H.M, already we understood what is S.H.M. So then what are the basic terms related to the S.H.M? So the first term, that is the amplitude. So what is the amplitude? The maximum displacement of the particle from the mean position is called the amplitude. What is that? The maximum displacement of the particle, from mean position is called amplitude. From mean position is called amplitude A. Chala, good. Amplitude A. So let's say, so the particle has started from mean position and it moved to the right extreme. So here the plus A is the amplitude, right extreme. And if the particle started from the mean position and it moved towards the left, so here the left extreme position is called minus A. The maximum amplitude, here it is minus A, here it is plus A. That's it. Okay, so it is denoted with A. Now the time period. What is the time period? So the time taken to complete one oscillation. So what is one oscillation, sir? So the particle started from mean position, again it has to get back to mean position. So what is that? So it will move from here to right extreme. So right extreme to the mean. So this is not the complete time period. Again to the left extreme and again to the right extreme. So it's a time taken, for one complete oscillation. One complete oscillation is called the time period. Okay, so which is denoted with T, capital T. So this time period T is equals to, we can write either 2 pi by omega, or we can write this way. So the omega angular velocity, you know, right? Angular frequency, you know, right? So which is 2 pi by T. So from here, so the T time period is equals to 2 pi by omega, or you can also write, so the omega is equals to 2 pi f, right? So this also we know. So this is the time period. See, then, so what is the time taken from mean to the right extreme if they ask? So the total is divided into 4 parts. So the total time period T is divided into 4 parts. So that's why from mean to the right extreme T by 4, right extreme to the mean T by 4, so mean to the left extreme T by 4, and left extreme to the mean again T by 4. Understood? So from here to here T by 4, then T by 4, then T by 4, then T by 4. The total is T time period. Done. Simple concept. Sure. So the same thing, the frequency is the number of oscillations in 1 second. So which we can write it as F is equals to 1 by T. So you know the units of frequency, right? So the frequency units are Hz. So 1 by second, which is the Hz. So and the angular frequency also you know. So the omega is equals to 2 pi by T. And then also you can write omega is equals in terms of frequency as 2 pi f. So then the time period is equals to 2 pi by omega. So this basic information you already know. So the omega will be taken in radian per second and frequency will be taken in hertz. Done. Chalo. So let's move further. This is important. The restoring force, already we discussed it, right? Why this slide has come here? So already I discussed it, so no problem. So it always acts, the restoring force, it always acts towards the mean position. So where, okay, new formula has come. Okay. So F is equals to minus kx, right? So then what is this k sir? This k is a constant, so which is written as m omega square. So the k value is m omega square. So from here, if you substitute, so the force is equals to restoring force. In place of k, you can write m omega square x. So minus, in place of k, you can write m omega square. So in place of x, x. Done. This is a restoring force. Chalo. So greater is the displacement from the mean position, greater is the restoring force, already we discussed. So the F is directly proportional to minus x. So why minus, what minus indicates? It always towards a mean position. So it doesn't mean that it opposes a particle's motion. No. Clear? Chalo. So the acceleration, important point. So we know that the acceleration is equals to the force upon mass, right? So here, what is the force? Which force? If the particle is making the S.H.M, which force acts on it? The restoring force. So in place of force, I am writing the restoring force minus kx by m. Okay, chalo. So let me write. So minus, in place of k, I am writing m omega square. In place of k, I am writing m omega square. So then x by m. So here m gets cancelled. The acceleration will be equals to minus a omega, sorry, acceleration a is equals to minus omega square x. So here a is equals to minus omega square x and a is directly proportional to minus x. So F is directly proportional to minus x, the restoring force, which means it always acts towards the mean position. Similarly, A is directly proportional to minus x. Am I going fast? Chalo, so let me go a bit slower. These are the basic concepts, you already know, that's why. And it's a recorded lecture, you can listen twice, right? So that's why I'm going a bit faster. So no problem, I'll go slow. So a acceleration is directly proportional to minus x, which means, so the acceleration always acts towards a mean position. So very important formula, you have to remember this, guys. And if they ask what is the maximum acceleration, so the magnitude of A max, magnitude, it's a omega square x. Remember this one, it's a omega square x, right? Sorry, omega square A, because the maximum displacement will be A, right? So the magnitude of the maximum acceleration is equals to omega square x. So acceleration will be maximum when the displacement is maximum. What is the maximum displacement? Which is amplitude, right? Sure. So let's say if the particle is moving from here, so then it's going to the right extreme, then the acceleration, if the displacement x is towards right, positive, so then what we can say, so the acceleration will be towards the mean. If the particle is moving x this side, so the acceleration will act towards the mean position. So acceleration always acts towards the mean position, restoring force always acts towards the mean position. Done this part? Clear everyone? Sure. So let's move further. So now the very important term, that is the velocity. So here let's say, so the particle has started from here, so it will have the velocity v, and then this side the velocity will be negative, we take generally. So see, for the velocity we take, let's say the right side direction is positive, so we consider the left side direction is negative. We take the sign conventions, right, for the vectors. So the velocity v square formula is given as omega square into a square minus x square. So what's the velocity formula? So the v square is equals to omega square into a square minus x square. So right along with me, you have to remember this. Okay, chalo. So what is v? So then square it, a, that's root omega square into a square minus x square. So here v is equals to square root of omega square, which is omega I am writing outside, so into square root of a square minus x square. So this is the equation for the what? So the velocity of the particle which is performing S.H.M. And what is the maximum velocity? So the velocity will be maximum at mean position. The velocity will be maximum at the mean position. So the velocity will be maximum at the mean position. So that means x is equals to maximum at mean position. Done? Chal. So what is that? At mean position x is equals to 0. So then the v max will be equals to, so the maximum velocity, omega square into, so a square minus x square is 0. So the mean position x equals to 0, right? So then the v max is equals to square root of omega square into a square. So from here, so the v max is equals to, so a omega. So the magnitude of the maximum velocity is equals to a omega. So the magnitude of the maximum velocity is equals to a omega. So clear? So this is velocity can be plus or minus. Okay guys, just note it down. I'll just have some water. Now it's clear. So done these formulas. So chalo, so let me go for the formulas. Before going for the formulas, so let's summarize the things. So what we learned, so major formulas, so that is f is equals to minus kx is a simple harmonic motion condition, and then so the k is equals to what? M omega square. So from here, so you can write, so the f is equals to minus m omega square x. Done this part? Chalo. So and then we also wrote, so the amplitude is a maximum displacement. Amplitude is a maximum displacement of the particle which is performing S.H.M. and then we have seen the time period t is equals to 2 pi by omega, or omega is equals to 2 pi f. So this also we learned. Chalo. So next we have studied, so the acceleration. So the acceleration is equals to minus omega square x. It is also always towards a mean position. And then, so what is the magnitude of the maximum acceleration? So which is omega square a, or a omega square. And then, so the velocity of the particle which is performing S.H.M is equals to omega square into a square minus x square. Chalo. So from here, so the velocity v is equals to omega into square root of a square minus x square. And then what is the maximum velocity? So the v max is equals to, so the omega into a. Omega into a. At maximum velocity occurs at the mean position. Remember this one, the acceleration will be maximum at the extreme positions and velocity will be maximum at the mean positions. I'll write that point. The velocity is maximum, the velocity is maximum at mean position, at mean position. Chalo. So then, so the acceleration is maximum at the extreme positions. Acceleration will be maximum when the displacement is maximum. So where the displacement is maximum? So the displacement is maximum at the extreme positions. Done this point? This is the basic information. So now, so based on this, there were questions in previous years. So those questions we'll discuss now. So chalo. So when the question is displayed, you have to try it on your own. Pause the video, try it on your own. So here, just a minute guys. Yeah, sorry guys. So done this question. The distance covered by a particle undergoing S.H.M in one time period is. So in one time period, how much distance does it cover? One time period means, so the mean position to the extreme position, and then from extreme to the mean again, from mean to the left extreme again, and from left extreme to the mean position again. Okay, from here to here a, and again from here to here a, and from here to here a, and again from here to here a, and from here to here a. So the total distance covered in one complete time period is 4a. That's it, the simple question. Done. Chalo. So next. So a pendulum is hung from the roof of a sufficiently high building and is moving freely to and fro like a simple harmonic oscillator. So the acceleration of the bob of the pendulum is 20 meter per second square. What they gave? The acceleration a is given. What is that? 20 meter per second square is given. So then at a distance 5 meters. So the displacement is given, which is at 5 meters. Right? Chalo. So from the mean position. So the time period of the oscillation, what we have to find? The time period of the oscillation. So first try to understand the given information. The time period is 2 pi by omega. So the 2 pi is constant, but omega we have to get. So what's the given information? So the acceleration is given 20 meter per second square. So if the particle is making S.H.M, then so it's moving, this is a mean position, let's suppose, then so it is at a distance x is equals to 5 meters. Now the particle is somewhere around here. So now the acceleration will act towards some mean position always. So the acceleration equation that we know as a is equals to minus omega square x, right? So this acceleration, shall I take it as negative? A is minus 20 is equals to minus omega square into the displacement is given. What's the displacement? So 5 meters. So minus minus cancel. Omega square is equals to 20 by 5, which is 4. So then omega is equals to 2 meters. So we got the omega. So then find the time period. right? So what's the time period? 2 pi by omega. So 2 pi by omega is 2 radian per second, 2 cancel. So the answer will be, time period is pi seconds. So the answer will be pi seconds. Option 2 is the correct one. Done? Chalo. So let's move further. So what's the question says here? So a particle is executing simple harmonic motion, S.H.M. So its maximum acceleration is alpha and its maximum velocity is beta. So what they gave? So the maximum acceleration A max is given alpha and V max is given beta. Chalo. So what is A max formula? Just now we have seen. So the A max is omega square A, which is given as alpha. And so what is V max? Maximum velocity A omega, so which is equals to beta. Chalo. So I need the time period. So for the time period, actually I need the omega. The time period T must be equals to 2 pi by omega, right? But I don't know omega here. So what I am doing is, let's consider this is the equation number 1. So let it be the equation number 2. So let's divide equation 1 by 2. So from there we can cancel 1 omega, then we'll get another omega value. Simple calculations here. So omega square A by A omega divide is equals to alpha by beta. Omega omega cancel, A cancel. So here I got 1 omega is left in the numerator, which is alpha by beta. So I got omega. So then I'll substitute here. The time period is equals to 2 pi by, in place of omega I'll write alpha by beta. So which is nothing but this beta will go up, 2 pi beta by alpha. 2 pi beta by alpha. Option 1 is the correct answer. Done, clear everyone? Understood? Chal. So next. So one more question we have. So what's the question says? A particle executing linear simple harmonic motion with an amplitude of 3 centimeters. When the particle is at 2 centimeters from the mean position, so the so the magnitude of its velocity is equals to that of acceleration. So that of its acceleration. So then time period will be, see, simple question, nothing is there. So here, so the harmonic motion, simple harmonic motion, the amplitude is given. What's the amplitude? 3 centimeters. Chalo. So when the particle is at 2 centimeters, that means, so the displacement of the particle at which is at 2 centimeters, at that time the magnitude of its velocity, the magnitude of the velocity is equals to that of the magnitude of the acceleration. Done. So what's the velocity formula we know? So omega square into square root of a square minus x square. So this one magnitude of the acceleration is omega square x. Done. So from here omega square cancel. So the square root of a square minus x square, what do we have to find? So then the time period of the acceleration, right? Sorry, here not omega square, it's a omega, right? So it's a omega into square root of a square minus x square is equals to omega square a. Done. Chalo. So omega cancel from here. So the square root of a square minus x square is equals to a omega. So let's squaring on either side. So we get, so a square minus x square is equals to here a square omega square, squaring on either side. So from here, or else let it be, let's do, we need omega only, right? So let's do the calculations. So what is a square? Amplitude is 3, so 9 minus x square 4, so which is equals to a into omega. What is a? 3 into omega. So let it be, so here root 9 minus 4, root 5. So this is root 5 is equals to 3 into omega. From here the omega is equals to root 5 by 3. Done. Doing the calculations with me. Chalo. So I need the time period. So I got omega. So shall I find time period? 2 pi by omega. So 2 pi by, what is omega? Root 5 by 3. So send this 3 to upside. So then we get, so 2 pi into 3 by root 5. So which we get, so 2 pi into 3 by, any calculation mistake we did? So its amplitude is 3 centimeters. So when the particle is at x is equals to 2 centimeters from the mean position, okay. So the magnitude of its velocity equals to that of the acceleration. So the magnitude of the velocity will be omega into square root of a square minus x square, fine, which is equals to the acceleration is what? So it's not maximum acceleration, it's a just acceleration, guys. Yes, here we did mistake. So it's a not maximum acceleration, it's just the acceleration. That's why the magnitude of acceleration, just write omega square x. Understood where we committed mistake? Omega square a I took, that's a maximum acceleration, but they said simply the acceleration, right? Chalo. So here omega square into x. Chalo. 1 omega cancel. So here omega into x is left. Chalo. So now substitute the values. This is going to be, so a square minus x square. So which is 3 square minus x square, which is 2 square, which is equals to omega. We have to find x is what? 2. So then I can write this is root 5, which is equals to omega into 2. From here, so what's the omega value? So root 5 by 2. So done, we got the omega. So then what's the time period? So the time period is equals to 2 pi by omega. So which is 2 pi by, in place of omega, root 5 by 2. So 2 will go up, 2 into 2, 4 pi by root 5. So 4 pi by root 5. Clear? Understood, guys? Chal. So a particle is executing S.H.M along a straight line. Its velocity is at distance x1 and velocity at x2 from the mean positions are v1 and v2 respectively. So its time period is, okay. So let's do one thing. It's actually the standard result. You have to remember the formula also. So first let me do the calculations. So at a distance x1 from the mean position, let's say this is a right extreme position, consider. So now at a distance x1, its velocity is v1. So then at a distance x2, its velocity is v2, let's say. So then we know the what are the velocities formulas, right? So the velocity v is equals to omega into square root of a square minus x square, right? Chalo. So then, so here the velocity v1 will be equals to, shall I write omega into, so a square minus, so the x1 square, shall I write? So the first displacement is the x1 square, right? Chal. So then what else we need? So the v2 is equals to, so omega into, so a square minus x2 square, the velocity v2 at the x2 position. So let's do squaring on either side. Let's better use the v square formula only. So the v1 square is equals to omega into a square minus omega into x1 square, omega into a square minus x square, right? So then, yeah, okay, let it be. So then v2 square is equals to, so omega into a2 square, a square minus omega into x2 square, right? So let's do one thing. So we need only v terms and the omega terms. So let me subtract these terms. Let me subtract these terms so that I'll get, this will become plus. So this will get cancel. So here v1 square minus v2 square is equals to, so here this is plus, this is minus. So I can write omega x2 square minus omega x1 square. So which is v2 square minus v1 square is equals to omega common. So which is x2 square minus x1 square. So we actually need the time period. So for that, first I am calculating what is omega. Omega is equals to v2 square minus v1 square by x2 square minus x1 square. Yes or no? So this will become plus. So then if I subtract, this becomes plus, right? So omega x2 square minus omega x1 square, here v1 square minus v2 square, this one. This is v1 square minus v2 square, v1 minus v2, right? So then, so here it is. So v1 square minus v2 square. Done, guys? Understood? Chal. Next. So let it be the omega. Then I have to find what is the time period. So I know the time period t is equals to 2 pi by omega. So the time period t is equals to 2 pi by, so in place of omega I am writing, so v1 here omega square, right? So you should tell me, right? So omega square. Yes, so omega square. So then chalo, so here we got, so the omega square is equals to what we got, v2 square, v1 square minus v2 square by x, just the calculations, that's it. So x2 square minus x1 square. So from here the omega will be equals to the square root of v1 square minus v2 square by x2 square minus x1 square. Chalo, so that omega I am substituting it here. So which comes out as, so v1 square minus v2 square by x1 square, x2 square minus x1 square. So which comes out to be 2 pi into root of, so here x2 square minus x1 square by v1 square minus v2 square, right? Understood everyone? Clear? Chal. So the correct option will be 2 pi into, so x1 square minus x2 square by v1 square minus v2 square. So the option, so this can be any way you can write, however in the roots, right? Here x2 square minus x1 square by v1 square minus v2 square, or x1 minus x2 square, anything, any way you can write it. Just reverse also you can write the terms, because we are doing the square, right? However it doesn't matter, and in the square that value should not be negative. Okay, so the option 2 you can take. Done guys? Everyone clear with this? So this is the standard result you have to remember. Chalo, so this question just the formula based question, the previous one, take it as a homework. Done? Chalo, next. So this question also you take it as a homework, homework 2. So the simple question. So this one you can directly answer here itself now, homework 3. And this question also you can solve it easily, homework 4. This is also easy, the homework 5. Chalo. So that from the differential equation we'll see it in the next session. Okay guys, so till then keep studying. All the very best. Bye guys.